I again welcome you all guys. So in the week 9 assignment 9, we'll try to understand the options, answers, explanations about all these 10 questions present here. So let's get started guys. Now if you look at the first question is what is the worst case complexity of selection sort? So if you have studied about selection sort, the worst case complexity is big O of n square. So if you have not understood this, why it is big O of n square, I personally recommend please go and understand about the selection sort once more, and then only you will be able to understand why its complexity is big O of n square. For the next question, if you look carefully, again it is an important question where it is asking the best case and worst case complexity of ordered linear search. So if you look at ordered linear search, in that case, if you are getting the answer at the top, in that case big O of 1 is going to be the best case, whereas in the worst case it means whether you have not got or you may have got at the last array, at the last index. In that case big O of n will be the worst case complexity. So if you have not gone through linear search, please go through the linear search, then only you will be able to understand about the best case and the worst case. So as per the question, option D is the correct answer. Now let's look at question number 3. In the question number 3 it says, given an array with some elements and a key, what are the mid values of the corresponding array elements generated in the first and the second iteration? Okay, so as you can see carefully, it is asking about the first and second iteration only. So if you look at the first iteration, in the first iteration we will look at the elements. First of all, we can see there are 1 2 3 4 5 6 7 8 9 elements. So if you look at the 9 elements, and if I divide 9 by 2, we are getting 5. So fifth element will be the mid element. So let's see, 1 2 3 4 5. So 85 is the mid element in the first iteration. Okay, now once we have got 85 as the first iteration, we'll look at the key. The key is 34. That means we won't be getting that element in this part because 34 is less than 85, and therefore we'll have to look in this section. Now in this section, if you look carefully, we have again how many elements? If you consider 85 also in that way, or if you don't consider, then also if you look carefully, we have 4 elements here, that is 12, 34, 47 and 62. So if you have 4 elements and if you divide 4 by 2, we are getting the answer as 2. Means your second element will be the mid element. Therefore that is 34. So the first mid element is 85 and second mid element is 34. In the first iteration it is 85 and in the second iteration it is 34. Therefore option B will be the correct answer. Now let's look at the next question. The next question is, when a binary search is best applied to an array. Means it's asking that if you are applying a binary search, in which situation it will be best applied on an array. So the best applied scenario is only one, which is when the array is sorted. Therefore option B will be the correct answer. Means if your array is sorted, in that case binary search will take the least amount of time. Okay. Now let's look at the next question, that is question number 5. Question number 5 says, consider an array with 5 elements, that is 5, 4, 9, 1 and 3. 5 elements. Apply the insertion sort. So we have to apply here insertion sort. Consider the cost associated with each sort is 25 rupees. So it is saying that in every sort you have to apply cost of rupees 25. Then it is asking what is the total cost of the insertion sorting for the entire array. Means for this array, if you apply insertion sort and for every sorting step, if you are considering the cost as 25 rupees, then for complete sorting, what will be the amount required? So as per me, the option C will be the correct answer. So let's see how option C is the correct answer. Now if you look at insertion sort, what it does, it will start from index 1 first of all. What it will do, it will check whether the index 0 is greater or smaller. If index 0 is greater, then a swap will take place. Okay, so what will happen after first iteration, after first sorting, you will have the element as 4, 5, 9, 1, 3. Okay, now as I have done sorting once, therefore 25 rupees has been spent. Okay, now we'll again do the sorting. We'll go to the next index, that is 9, and as you can, it will check out whether it has to be inserted somewhere in this sorted array or not. So that is possible by checking each and every element, and if any element is smaller than the element which we are searching now, okay, so in that case we'll do the sorting, otherwise we'll not do the sorting. So in this case, sorting is not required, so therefore no money will be spent. Okay, now let's look at the next element, that is 1. Now if you look carefully, 1 is smaller than all 3 of them, so the sorting is required. So this time we have to do the sorting. So what will happen, this has to be inserted at the correct place. So its correct place will be at the index 0. So 1 will come here and all other will be shifted. So 4 will come here, 5 will come here, 9 will come here, and we have done one more sorting, therefore 25 rupees is spent. Okay, now we'll look at the last element, that is 3. Now as 3 is again smaller than few of the elements, so we'll have to check out where we have to insert it. Okay, so sorting has to be done. Now if you look carefully, the sorting will be, once the sorting is done, it has to be inserted at this position. Okay, and after inserting, the other elements will be shifted right. Therefore the final answer will be 1, 3, 4, 5 and 9. So one more sorting has been done, so one more 25 rupees will be spent. So the total amount spent is 75 rupees. Therefore option C is the correct answer. I hope you have understood that why only 75 rupees spent, not more than that. Because if you look carefully, in our second step, sorting was not done. Therefore we have not spent any money. Therefore the final answer will be 75 rupees. Now let's look at the next question. The next question is quite interesting. It says, select the code snippet which performs unordered linear search iteratively. So here we are talking about unordered linear search, and you all know that if you're creating a function of unordered linear search, we'll first of all have the parameters like we'll take the array, we'll take the size of the array, and we'll take the element which we have to search. And for implementing the logic, you will have to apply a for loop, and in that you have to check whether this data is present in this array or not, and wherever it is present, that index you will have to return. Okay, now if you look carefully in the logic section in this for loop, so this for loop, if you look at the first case, if you look at this case, in this we have the for loop which is running from index 0 to index size -1. That's correct, no issue is there. And inside there is if condition also, where we are checking whether at any index the data is matching or not. And if there is a match, if the condition is true, what we are doing, we are passing that I value to the index, and once this match is done, no need to check out anything else, because our aim is fulfilled. Because what was our aim? We have to search whether that data is present in the array or not. So it is good that we should apply the break statement. Okay, so once we apply the break statement, we'll be outside this for loop, and after that there's only one statement left here, that is we are returning the index. So if you look carefully, option A is the correct answer because it is fulfilling everything. Now let's also try to understand why option B, C and D is not correct. So if you look carefully, in option B, we are matching, we are checking whether the data is present in the in any index or not. But we are, after a correct match, what we are doing, we are directly applying break and we are coming outside the for loop and we are returning the index. So as if you look carefully in this scenario, we are not at all updating the index value at any place. So as index was declared here, it will be having a garbage value. So what will happen in this scenario, this index will be returning the garbage index, which will be having the wrong answer. Okay, therefore option B is not correct. Now if you look at option C, in option C, what is happening in this, we have again a match here done, fine. Once the match is done, what is happening, it is taking the index, value of I and putting in the index, that's correct. And then we are applying the continue statement. Now what this continue statement will do, it will repeat this for loop again and again, and it will run till size -1 index. Okay, now here the issue is that if you are getting a match at some place, after that again it will keep on continuing and execute till the end of the array, first thing. Second thing is that if you are getting a match at some position, let's suppose index 2, and let's suppose there is a value, same value at index, let's suppose 8, then it will not take this index because it will take the index of the 8 index it will take, and therefore we will be having a confusion that whether as per the question we will not get the answer. The question is basically that we have to search, okay, and we have to find whether the data is present or not and at what index. Okay, now if you look carefully, in two ways it may have problem. First is that it will take more time. Because it is executing the complete loop. Okay, so if it is executing the complete loop every time, whether it has got the data or not got the data, in that scenario that is not correct. Okay, so the best answer will be option A only. Okay, option C can be correct, but the best answer is option A. I hope you have understood why I am saying option A as the correct answer. Now let's look at the next question. The next question is quite interesting, where we are actually interested in understanding the preprocessors. So if anyone is not having the idea of preprocessor, let's understand that also. Now if you look carefully, in this preprocessor directive, we have two hash defines. Now what is the use of hash defines, or what is the use of preprocessor? If you are aware, if you are not aware, let's try to make me understand. Preprocessors are those things which are executed before the execution of the main function. So what actually it does, inside the program, not only in main function, in the complete program, it will check out that where this first part of the definition is present. Okay, and wherever this definition will be present, it will replace and put it there. Okay, so you can see at this section function 1 is present here. So what will happen, before execution of the main function, it will replace this, okay, and put this here. Okay, similarly function 2 also is present here. It will replace this and put this one here and then start the execution. Okay, so in order to make you understand this in a better way, I'm just taking an example, okay, so that we can practically understand. So let's try to see this practical example. Okay, what will happen? Let's see guys, here I have taken the code here. In this, if you see, what will actually happen is that before execution of the main function, this function 1 will be replaced by this one. Yes or no? So what actually is going to happen, that I am trying to show you here. Look here carefully guys. So what will happen, this will be taken from here, okay, and you can just imagine something like this. This will be removed from here and it will be pasted something like this. Similarly, for the second section, it will be taken and copied from here. Okay, copied from here, and this function 2 will be replaced something like this. I hope you're getting my point. Okay, so this will happen as a preprocessor directive. Okay, means this is the step happening whenever you are having any hash defined. Okay, so please keep in mind, whenever you are having hash defined, this pre-processing will take place and will actually replace everywhere before executing the main function. Okay, so what I'm going to do is I'm going to keep it something like this only, and first of all I'll just copy this complete code from here, and just to make you understand that if I keep the code something like this here, and I'm just taking this, I'm just replacing here, just to make you understand in a better way. Look carefully, guys. So I've taken both the scenarios actually, that in first case we are taking the data from hash define, and second it is actually the same data. Okay, I mean it seems that no hash define has been done here. So in both cases you will get the same answer. That is the thing which I am trying to make you understand. In the first scenario, I mean in this scenario, what is happening? It is actually taking at the preprocessor timing. Okay, but here I have just taken it directly. So for both the scenario, if you are getting the same answer, you can assume that my explanation is correct. Okay, so let's try to compile it. So as I am using Ubuntu here, I am using the GCC compiler. I'm just compiling it. Compilation has been done successfully, and then I'm going to run the program. So see, when I'm running the program, can you see I'm getting 5.3 and 5.3 as the answer? So I hope it is clear to everyone. Now let's try to understand that how it is correct. Now if you look carefully here, what is happening? A greater than B, I mean this is our ternary operator. So what will happen? This ternary operator will be placed here. So I mean let's try to understand this part where everything is written. So it is written here 3 plus A greater than B question mark B colon A is written there, and if this condition is true, we'll execute this part. So let's try to understand whether this part is true or not. So let's try to put all the values. 3 plus A is what? A is again 3, and 3 greater than B, B is 5 question mark B is 5 colon A. So first of all, execute this section and then we'll add up with this. So this ternary operator, what it does, it will check this condition, and if this condition is true, it will execute and take the value 5. If the condition is false, what it will do, it will take the value of A, and the value of A is what? 3. Now 3 is greater than 5. This condition is what? It is false. Now as the condition is false, it will take the value of this complete execution as 3, and here we have 3 plus 3 is going to be what? 6. So this is this complete setup, I mean this from here till here, we are going to get the value as 6, and now we are comparing 6 greater than B. What is the value of B? B is 5. Now 6 is greater than 5. This condition is what? It's true. So as it is true, therefore we'll execute this temp section, and this temp section, if you observe carefully, we are applying the swapping condition. I'll not go in detail about that. I'm sure you are aware of that. So we are swapping the value of A and B. The value of A was what? 3. Now the value of A will be what? 5, and the value of B was 5, so it will become 3. Now when we are trying to print A and B, the value of A will be printed as 5 and value of B will be printed as 3. Therefore 5 and 3 will be the printed, and option which is containing this as the answer will be the correct answer. Okay, so let's move to our coding part. Okay, so if you look carefully here, option D has been selected, and that's how option D is the correct answer. Now let's look at the next question. The next question is question number 8. Now in question number 8 we have again one array that is containing 5, 4, 3, 2, 1 as the elements, and it is asking what are the steps of insertion done while doing the insertion sort in the array. Okay, now as we have elements 5, 4, 3, 2, 1, so if you apply the insertion sort, what will happen? It will first of all take the second index, index 1, and will check whether it is smaller than the first index or not, or 0th index or not. If it is, then sorting will take place. So what will happen? It will swap the data. So 4 will come here, okay, 5 will come here, and 3, 2, 1 will remain as it is. Now this complete part is sorted. Now we'll take this index 2 value. Now as you can see, index 2 is again smaller than 4 and 5, so it has to be brought to the correct position. So it will be brought to the index 0, and 4 and 5 will be shifting. Therefore after sorting we'll get this as the answer. Now again, if you take at index 3 is again the smaller value, so it has to be brought to the correct position. Now the correct position is index 0 again. So what will happen? After this sorting, 2 will come here, and 3, 4 and 5 will be adjusted right hand side, okay, and this will be the next sorting value. After that, if you take at the last index, that is index 4, again this is also a smaller value, again sorting has to be done. Therefore this will be brought to again index 0, because why I am bringing it to index 0? It's not the rule to bring to index 0. The rule is it has to be kept in a position where it is smaller, and it is at the correct position, to say. So if you look carefully, if you are bringing it at index 0, then that is the correct position. If this would have been, let's suppose, something 2.5, then it has to be brought between 2 and 3, yes or no? So once you are sorting here, this 1 will be brought to the index 0, so 1 will come here, and all the other elements will be shifted 1, and therefore this will happen, and now it is completely sorted. So the example or the answers which is showing this as the answer, that is the correct answer. So if you look carefully, option A is the showing those all iteration steps, okay. Therefore this option A is the correct answer for this question, okay. Now let's look at the next question again. Now next question is again quite interesting, and it is all again about the preprocessor directive. Now in this question you have to please keep in mind, we are actually executing the if condition in the preprocessor directive. Yes, we can execute if condition even in the preprocessor directive, okay. So what is happening here, guys? If you look carefully, here we are trying to execute a if condition. So if A is equal to 1, so if this condition is true, this has defined will be executed, else this has defined will be executed. Now it all completely depends upon what is the value of A. So you can observe the value of A is not defined above. So by default the value of any has defines, if you are doing in this way, the value is by default taken as 0, okay. So if the value of A is by default 0, so 0 equal to 1, this condition is what? False. Now as this condition is false, what will happen? This has defined will be executed. Means inside the main function, wherever there is B, that will be replaced with 1, okay. Therefore once this is done, the job of preprocessor directive is done, okay. Now let's execute the main function, and in this main function we have only a printf function, so that is executed, and there the answer is there 1 has to be printed, so 1 will be printed on the screen. Therefore option B is the correct answer here. If before this if condition, if I would have written has defined A, and I would have written 1 here, then the value of A would have been 1. In that case this would have been the correct answer, this condition would have been correct, and in that case we'll have to execute this as the definition part, this won't be executed. Therefore all B will be replaced with 0, and that in that case B will be 0 will be printed. But as this has defined is not done there, therefore by default A is taken as 0, and therefore condition becomes false, and accordingly the value of B is replaced with 1. Therefore 1 is printed here. So I hope this is clear to everyone. Now let's try to execute and understand our question number 10. Now in this question, if you look carefully, here again we have one has defined. Now this is a quite interesting question. This says that here we have has defined A10. So before executing the main function, we have what do we have? We have A10. So wherever we have A, that will be replaced with 10. Okay. Now when you are coming inside the main program, and if somewhere initialization of variable, same name variable is done, then there is a compilation error. Means, please keep in mind, your variable which is written in the has defined, and if you are initializing or if you are declaring a variable of the same name, in that case what will happen? Look carefully guys. Why there is a mistake? So what will happen? This A will be replacing everywhere. So if it is replacing everywhere, so this here it will be 10. Here also it is going to be 10. And for this line, I am just writing here separately. It is what? Int A equal to 50. So if this has defined will take place, this will replace this also with 10. Now just tell me what will happen. Int 10 equal to 50. Does this is having any meaning? Tell me guys. Is it going to have any meaning? I think there's no meaning. You cannot write int 10 equal to 5. Can you write? Can we do any initialization? We all know that at this place it should always be a variable. Yes or no? But as we have defined a macro here, that is A10. So what will happen? This will replace A with 10, and it is going to create a big confusion here, or you can say it's going to create a big problem, and this will always result in an error. Okay, so therefore option D will be the correct answer here. Please keep in mind. So one rule you can set in mind is that whatever variable you are taking in the has defined part, that variable should not be taken. That should not be taken as a variable inside the main function or anywhere, because once you are declaring it, there itself it will become an error. Okay, clear? So that's why it's giving us the compilation error. So I hope you have understood it. If still you have any confusion, any doubt in the explanation section, you can comment me in the chat box. Okay, I'll try my best to explain you once more. Thank you guys.